In this question, you're given a cheetah undergoing constant acceleration. So when the acceleration is constant, we can use the 4 equation of motion. Then we are given that it starts from rest, so u is 0, reaches a speed of 29 meter per second, v is 29, in time duration of 2 seconds, so t equals to 2, and then maintain at this speed for 15 seconds. So for the last 15-second duration, we know that the velocity is constant, so the v equals to u, which is equals to 29 meter per second. This implies that the acceleration will be 0, which is constant also. Okay, part A, you're asked to calculate the acceleration of the cheetah. I'm going to use the third equation. So A equals to v minus u over t. V is 29, u is 0, time is 2 seconds. Okay, we need to substitute unit. So with that, you should work out the acceleration to be 14.5 meter per second squared. Okay, let's move on to part B. In part B, you are asked to calculate the total distance traveled by cheetah. There are two methods here. One method is to use the area under the graph in part C. So in part C, you are given the speed time graph for cheetah. So to find the distance, I will have to find the area under the speed time graph, which is this area here. Okay, so until 17. So this is the area of trapezium. The length from here to here, this is 15. Okay, then from here to here, this is 17. So half times sum of the parallel side times the height, that will give me a total distance of 464 meters. So this is using area under the graph. Or another method is to use the equations of motions. But the acceleration for the whole duration of 17 seconds is not constant. So I can't use it for the whole 17 seconds. I will have to break it up into 2 parts. So I will consider first 2 seconds. In first 2 seconds, the acceleration is constant and the value is 14.5. I also know that initially the cheetah is at rest, so u is 0. It's given that the final speed is 29 meter per second. So this is what I know. Okay, of course time is 2 seconds. So to find s, I can actually use any formula. So I'm going to use s equals to ut plus half at squared. So u is 0, so that will give me half times a, which is 14.5, times t squared 2 squared. So that will be the distance during the first 2 seconds. I'm going to call this S1. Okay. Next, what about the next 15 seconds? So for the next 15 seconds, I'm going to call this distance S2. What do we know? We know that the acceleration is 0 because the u is the same as the v, which is 29 meter per second. Okay, notice that I cannot combine the first 2 seconds and the next 15 seconds because the a are different. Okay, so if you combine these two, it will be wrong. So now let's come back. How do I find S2? I'm going to use the same formula, s equals to ut plus half at squared. Okay, you can use any formula that have s, because you have t, you have a, you have u, you have v. So S2 will be equals to ut, u is 29, t is 15, plus half at squared. A is 0, so this whole term disappeared. So this will be my distance S2. So to find the total distance traveled by the cheetah, I will have to take S1 plus S2. Okay, the first 2 seconds plus the distance in the next 15 seconds. And that will also give me, if you work that out, 464 meters. Okay, if you notice the first 2 seconds, this is actually the area of the triangle here, and the next 15 seconds, this one here, is actually the area of a rectangle, this one. Okay, so whichever methods that you use, you should end up with the same answer. Now let's move on to C. Part C, you're asked to sketch the distance time graph, the speed time graph. Okay, the speed time graph for the antelope during the chase. So refer back to the question. You're told that the antelope takes 0.5 seconds to react, so he will start at 0.5 seconds. Accelerate for 2.5 seconds. So if this is 0.5, accelerate for 2.5. So 0.5 plus another 2.5 will be at 3 seconds. So the speed of the antelope will be at 25 meters per second given in the question when the time is 3 seconds. So this is 1, 2, 3. So this is my 3 seconds and the speed is 25. So this is the point. So you have to draw a line from 0.5 here to t with 3 seconds. Okay, it should be a straight line. Yeah? This one not very well drawn. I'm sure you can draw better. And this one is constant at 25 meters per second. So this is for the antelope. Next, part 2. How far apart are the cheetah and the antelope at t equals to 15 seconds? So in part 2, I want to find the difference in the distance between the two. Distance covered by cheetah, I already worked out in part B. Okay, so I don't have to calculate again. That will be 464 meters. What I need to calculate now is the distance traveled by antelope. Okay, just like in B, you can use either of the methods, but I'm going to use area under the graph. So to find the distance traveled by antelope, it will be the area of this trapezium. So half sum of the parallel side. This is 3, right? This is 17. So 17 minus 3, that will give me 14. This one is 0.5, here is 17, so this will give me 16.5. So the sum of parallel sides will be 14 plus 16.5 times the height, which is 25. And I will end up with 381 meters. Okay, leave your answer to 3SF. Okay, if you read the question, you are told that the cheetah and the antelope initially are 100 meters apart. So that is to say the position of cheetah is actually 464 minus 100 meters. Okay, because they are 100 meters apart, that will give me 364 meters. So the difference in the distance between the antelope and the cheetah should be 381 minus 364, which is 17 meters. So here the antelope is still ahead of the cheetah despite traveling less distance. Okay, because of the 100 meters apart initially. Okay, now we move on to part 3, where you are asked to sketch the distance time graph. So let's label the axis. Distance unit is meter, time, the units will be in seconds. So at t equals 0 for the cheetah, we know that u equals to 0. So this implies that the gradient initially should be 0. Okay, so at time t equals 0, the gradient here should be 0. So you can't draw your graph starting like this, okay, because the gradient here is not 0. You have to draw a gradual one like this, okay, where the gradient here is 0. Okay, now let's take a look at what happened during the first 2 seconds. So according to the question, in the first 2 seconds, it actually undergo acceleration, which is 14.5 meters per second squared. So if it's accelerating, this implies that the speed is increasing. If the speed is increasing, then the gradient of the distance time graph, which gives you the speed, must also be increasing. So gradient is also increasing. So from t equals to 0 to t equals to 2 seconds, I must show increasing gradient. Okay, and for the next 15 seconds, okay, then the next 15 seconds, the acceleration is actually 0 and the velocity is constant at 29 meters per second. Okay, so let's mark our axis. This is 2, and then the critical value will be when it's 17. So I have to show t at 0 t at 2 and t at 15 seconds. At t equals 0, the distance is 0. At t equals 2 seconds, I will need to find the distance. I have t, I have a, I have v, I have u. Okay, so you can use any formula. Let's use s equals ut plus half at squared. So the u for the theta initially is 0. This whole term disappeared, leaving behind half at squared. A is 14.5, time is 2, so that will give me 29 meters. Okay, so this is for the first 2 seconds. The distance traveled is 29 meters. So when t equals to 2, I will have to mark 29. But before I do that, I would like to know what happened when t equals to 17 seconds. We calculated in part B, the distance is 464 meters. Okay, so before you actually sketch the graph, bear in mind the difference in the distance. So if I have the whole scale, okay, the maximum is up to here. If this is 464, where is 29? 29 cannot be halfway here. You have to be all the way at the bottom. So approximately somewhere here. No need to be to scale, but at least approximately. Okay, so I'm going to draw this point again. I'm going to sketch the graph again. So initially gradient 0. Okay, gradient increasing. Then after that, the gradient is constant for the next 15 seconds. So the next point is here. Okay, so the first 2 seconds it should be a curve showing increasing gradient, and the next 15 seconds it should be a straight line that show constant gradient.